Hello class, today we will be talking about sequences. A sequence is an ordered list of numbers or other items. Each element in a sequence is called a term. So if we look here, we have what looks like a function table, and you have the sequences 2, 8, 14, and 20. And above each of those numbers, you have ace of 1, ace of 2, ace of 3, and ace of 4. That is what those things represent, is where it falls in the sequence. So that it simply just means that 2 is the first term, 8 is the second term, 14 is the third term, and 20 is the fourth term. It is very similar to a function table, and we're going to show how these are strongly aligned to different functions that we have talked about. Now, the first type of sequence we're going to talk about is an arithmetic sequence. An arithmetic sequence is a sequence of terms that have a common difference, which we will refer to as D between them. And when we think about common difference, we always think of it as what is being added. So even if it looks like we're subtracting every time, we're going to say that we're adding a negative. Now, to find the common difference, you take the second term and subtract the first term from it. So we'll do ace of 2 minus ace of 1. Now, we're going to look at two different formulas when we're looking at arithmetic sequence. The first one is going to be the explicit formula. And the explicit formula is used to find the nth term or any term that we're looking for of a sequence. So we can be given a sequence like we did earlier and have 4 numbers, but we can find the 50th term in that number easily using a formula. Now that formula is ace of n equals ace of 1 plus open parentheses n minus 1 close parentheses d. Now, the D is placed at the end of the formula to make sure that we don't make the mistake and add it with ace of 1 first. That is a common error that we could make if we rearrange that formula. Now, this tells you what each one of those variables stand for. Ace of n is the value of the nth term of a sequence, so basically your answer. Ace of 1 is the first term of a sequence. N is the actual place the nth term occurs in the sequence. So if we want to find the 20th term, we would put 20 in for n. And then D is our common difference. So let's look at this sequence here and see if we can find what the common difference is. If I take negative 15 and I subtract negative 22 from it, I can see that when I do negative 15 minus negative 22, I would get positive 7. So my common difference is 7 in this example. Now in this example, we have 7, 4, 1, negative 2, negative 5. Again, if I do 4 minus 7, I get negative 3. So my common difference is negative 3, not just positive 3. All right, now this time we're going to find the common difference, and we're going to use the explicit formula, and then we're going to find the 10th term. So if we're looking 3, 9, 15, 21, 9 minus 3 is 6. So my common difference is 6. So now I'm going to use my explicit formula. I'm going to replace ace of 1, and I'm going to replace D. So when I do that, I see that I have 3 plus n minus 1 times 6. Now, I have to distribute that 6 to the n and the negative and the minus 1 that's inside the parentheses. So I get ace of n equals 3 plus 6n minus 6. Now I have to combine like terms, and I get ace of n equals 6n minus 3. So if I ask you to do the explicit formula, you are not done until you get this final answer right here. The final answer is 6n minus 3. then now if I want to find the 10th term, I have to plug 10 in for 6, and 6 times 10 minus 3 is 57. Okay, here's another example. I want you to try to pause the video and try to solve this one on your own. First find the common difference, then use the explicit formula to come up with the explicit rule, and then find the 10th term. Okay, so if we are looking for the common difference, 10 minus 5 is 5. Then we're going to plug that information into our explicit formula. And we have, all right, so I'm going to replace D with 5. And my first term is also 5. So we do that. And then we're going to distribute. We get 5 plus 5n minus 5. When I combine like terms, I get a sub n is equal to 5n. Now, when I'm looking for my 10th term, I plug 10 in for n, and I get 5 times 10, so a sub 10 is equal to 50. All right, now we're going to talk about the recursive formula. A recursive rule for a sequence defines the nth term by relating it to one or more previous terms. So basically, we can use the recursive formula when I'm just trying to find the next term. Now, the recursive formula for an arithmetic sequence is a sub 1 is equal to whatever the first term is. That's why I have the question marks there. Then a sub n is equal to a sub n minus 1 plus d. Now, one of the great things about the recursive formula, there's no calculating to do. All I have to do is find the first term and the common difference and plug those two numbers in. Okay, so we're going to look at one example. We're going to find the recursive formula, then the next 4 terms. So if I have the sequence 3, 5, 7, 9, I am going to say that a sub 1 is equal to 3, and then my common difference is, I do 5 minus 3, and my common difference is 2. So I'm going to have a sub n is equal to a sub n minus 1 plus 2. So that is my recursive rule. Now, to find my next 4 terms, this is basically telling me that I'm going to add 2 to my previous number to get the next number. So all I have to do is add 2, and my next 4 numbers are 11, 13, 15, and 17.